Let's divide rational expressions. Now, to divide rational expressions is just like dividing fractions. Remember, with fractions, when we have a over b divided by c over d, the first thing we do is turn this into a over b times d over c. The bottom goes to the top, and the top goes to the bottom of just the second one. So let's look at a simple example to start with. We have x minus 3 over x plus 5 times, divided by x minus 3 over x plus 2. So the first thing we're going to do is we're going to leave the left one the same, the first one the same, and we change from a divide to a times, and the bottom goes to the top, and the top goes to the bottom. And we'll add parentheses to show our factors since now we're multiplying. We note that we have an x minus 3 on top and on bottom. Since the x plus 5 and the x plus 2 are not the same, we can simply write our answer as x plus 2 over x plus 5, and we have successfully divided this rational expression. Now, sometimes the expression we're given isn't quite that nice. Sometimes we've got a little bit more work ahead of us, like on this problem where what we need to do is factor it out. So factors of minus 15 add up to minus 2 are minus 5 and plus 3. Factors of 6 that add up to positive 5 are x plus 2 and x plus 3. I'm just going to keep factoring for now. I'll deal with where everything belongs in just a minute. X squared plus x minus 30 is x plus 6 times x minus 5. And factors of x squared plus 2x minus 24 are x plus 6 and x minus 4. So now, remembering that we need to change this to a times, the piece on the left stays the same. So the factors of the first one go on top, and the factors of the second one go on the bottom. And over here, we turn it around. So this x plus 6x minus 5, he actually goes to the bottom, and the x plus 6x minus 4 goes to the top. Now we look for common factors. We've got an x plus 3, an x minus 5, and an x plus 6, leaving us with x minus 4 over x plus 2. But we want to add the domain in, so I'm going to list the domain here afterwards. And I'm going to go back to my original and say if it's in this denominator, then it makes something a 0 on the bottom, so it's ruled out. So that gives us a negative 2, a negative 3, a negative 6, and a 4. But we have a couple of extras. Notice as well that this guy here ended up on the bottom. So I've already got the negative 6, but I also have to include this positive 5 because once in the denominator, it always affects the domain. So remember when you're doing division to watch your domain very carefully.